Alright, so this is the second video for section 11.1, and this should finish it off. Okay, so on this one, we're going to talk more about arc length. So if you refer back to the front page of your notes, and I'm going to write it up top here, we know that arc length can be found by taking the central angle over 360 and multiplying it by the circumference, which is 2 pi r. Okay, so as long as we have this formula and we use this formula, we can find whatever we need. Okay, so if I look at example 5, okay, I want to find the length of arc ER. This is an arc length. Okay, so I want to find this length here. Okay, well, this is an arc length. This is the length of an arc. Okay, so I'm going to use this arc length formula. So I'm going to say arc length, I'm going to abbreviate it, equals, I'm going to put C angle over 360 times 2 pi r. Alright, so let's look at our diagram and see what we can find out. Well, we know the central angle is 50, okay, and we know our radius is 7. Okay, so I'm going to plug those in where they go. So I can say my arc length equals, well, it's my central angle over 360. I said my central angle was 50, so it's 50 over 360 times 2 pi, and my radius is 7. Okay, now this is just like anything else. Okay, I can take this whole thing as it is right now, all of this, and put it into my calculator, and that'll give me arc length. Okay, I like to simplify it a little bit. You don't have to. If you're comfortable putting this whole thing in your calculator, that's fine. Okay, so I immediately see that there's zeros on both top and bottom, so I like to X those out. Okay, and then my 2 times 17, if I multiply those, that's 14. So I can rewrite this just to say arc length equals, well, 50 over 360 became 5 over 36 times, rather than saying 2 pi 7, I just like to say 14 pi, okay? And then I'm going to go ahead and plug this into my calculator. And like I said, you surely don't have to do that, but I like to. So when I do that, I get roughly arc length is roughly 6.1, and that means that arc ER is about 6.1 centimeters. And there's your answer. Alright, so let's look at example 6 now. Okay, this is pretty much the same thing. Okay, so I want to find the arc length of AC. So this time I want to find this arc length right here. I want to find the length right here. The difference is my central angle isn't listed right there. But remember, this is also the same as the central angle. The arc measure and the central angle are the same. So this is also my central angle measure. Okay, and this time my radius is 3. Okay, so I could write it out that arc length equals, it's the central angle over 360, so this is 50 over 360, and then times 2 pi r, which is 2 pi times 3. Okay, now once again, I like to simplify. You surely don't have to. You can put this in your calculator right now, but I like to simplify it a little bit. So that would just be 5 over 36 times, and then 2 times 3 is 6. Okay, and if I put that into my calculator, I get roughly 2.6. So I get arc length is about 2.6, okay, which means that arc AC is roughly 2.6, and this is in centimeters. And that's our answer. All right, let's look at example 7. We have to work a little bit harder in example 7. Okay, so it says find the length of arc ADC. So notice there is more than 2 letters in this arc. That just means we have to go in that order. We have to go from A to D and D to C. So if I look here, that means we have to go from A to D and D to C. So this is quite a bit bigger. Okay, Now if I look, my central angle of 80 is given, but this central angle would only help us find this arc. Okay, so I want to find this central angle here. Okay, well, if you remember, if we go all the way around in a circle, it's 360 degrees. Okay, so if this here is 80 and all the way around is 360, this has to be 360 minus 80, which is just 280 degrees. Okay, so I'm going to use my central angle as this 280 degrees. Okay, and then I do have that my radius is 12. Okay, so if I do my arc length formula, I know it's central angle over 360, which is 280 over 360. I'm going to multiply that by the circumference, which is 2 pi, and my radius is 12. Okay, so once again, I like to clean it up a little before I put it in my calculator. Don't ask why, I don't know. Okay, so those zeros go away, so 28 over 36 times, well, 2 times 12 is 24, so 24 pi. Okay, and then I like to put that in my calculator just like that. I know that 28 over 36 reduces more, so if you want to reduce that, go ahead. Okay, and I get my arc length is roughly 58.6, and that is, where are we at, feet? So in other words, ADC, arc ADC, is about 58.6 feet. Alright, so just a few more. Okay, find the length of LK. So LK is right here. Okay, I'm going to pause, or I want you to pause this video. Okay, this is an arc length. I want you to pause this right now. I want you to try it out. And then I want you to hit play again and we'll go over the solution. So go ahead and pause this, work it out on your own, and then we'll go over it. Alright, so hopefully you worked this out, and even more hopefully you got 30.6. Okay, so when you look at this, right here is your central angle, so we're going to use 135, plug that into our central angle part of the formula. Okay, and then our radius is 13, so we're going to plug that in right here. And then when you put this whole thing in your calculator, you should get 30.6 inches. All right, just a couple more examples and then we will be done with lecture. Okay, so these ones involve more words than pictures, so we're going to go ahead and draw a picture. Okay, so it says the length of an 80-degree arc is 12 centimeters. So if I have a circle, okay, let's say our arc is right here. Okay, and it tells us that this is 80 degrees. Okay, and then it also tells us the length of this arc is 12 centimeters. Okay, so this is my arc length. And this is my arc measure, but remember, this is the same thing as our central angle. So this is my central angle. Okay, so let me write out this formula. So we know arc length is equal to the central angle over 360 times the circumference, which is 2 pi. All right, so now I'm going to plug in what we know to our appropriate places. So the 12 is my arc length, so I'm going to plug that in right here. Okay, so I'd say 12 equals, okay, well, 80 degrees is my central angle, so 80 over 360 times 2 pi, and I don't know my r. That's what I'm looking for. Okay, so now we have this ugly problem, but we can use algebra to solve it. Okay, first thing I want to do, I always want to get rid of the fraction. So to get rid of the fraction, you always multiply by the denominator, so we multiply by the 360. Okay, when we do that, these go away. So 360 times 12 gives me 4320. So I can say that 4320 equals 80 times 2 pi r. Well, 80 times 2, guys, I can go ahead and put that together. 4320. 80 times 2 is 160 pi r. Okay, now I can divide both sides by 160. And I get 27. So 27 equals pi r. To get r by itself, I divide both sides by pi. So 27 divided by pi gives me about 8.6. Okay, so we have our radius is about 8.6, and that is in centimeters. All right, let's look at this last one. Okay, it says if the length of a, guys, there's a typo here. This should be 273 degrees, not 2,730. So 273 degree arc is 17.28 feet. Find the diameter. Okay, so if I draw this, okay, I know I'm dealing with a 273 degree arc. So if I start here, oh, that was weird. If I start here and I go around, I don't know, here's my center, let's say here. This is 273 degrees. Okay, and I know that when I do that, the length of that, which would be from here all the way around, is 17.28. Okay, so once again, this is my arc length, and this is my central angle. Okay, this time I want to find the diameter of the circle. Okay, so I want you to pause this video, and just like you did on number 9, I want you to go through the process, try to find the radius, just like we did up here. After you find your radius, you're going to turn it into your diameter. Okay, so go ahead and pause this video, and then once you're done, hit the play button, we'll go over it. Alright, so let's take a look at this. Alright, so we know our arc length is 17.28 and our central angle is 273. So when you plug those into the appropriate place, you should get this formula right here. Okay, now the first thing we do to simplify our algebra is get rid of the fractions. So let's multiply both sides by 360. When we do that, these cancel out. Okay, 17.28 times 360 is 6,220.8. And that equals 273 times 2 pi r. Now you don't have to do this, but I did. I went ahead and multiplied 273 times 2, which gave me 546. Okay, now if I divide 6220.8 divided by 546, I get 11.39 equals, and then these go away, so I'm just left with pi r. Divided by pi, I get r is roughly 3.6. Okay, but remember, the question didn't ask us to find the radius, it asked us to find the diameter. Okay, so to go from the radius to the diameter, we just multiply by 2, which means that our diameter has to be 7.2 feet. Alright guys, so now you have a Big Ideas homework assignment. Okay, so go to Big Ideas and it should be there. Now, rounding can be kind of funky when we introduce pi. So if you go to today's date, which is 4/18, okay, notice I have put the rounding in there. So just click on that link, okay, and this tells you what Big Ideas wants the rounding to be, because sometimes they round it kind of, I don't know, a little bit wonky. Okay, so if you're having problems with rounding, just go to this document. It should tell you how to round. Now, if you round it this way and it's not correct, then you need to go back and look over your work because you did something wrong.